Hi, I'm Ben, and I'm the lead designer of the Smith blade. Today, I'm going to show you how to disassemble yours. When you receive your Smith blade, it's going to show up in this box. You open it up, and your Smith blade is front and center. In the box, you'll also find some spare bits and your flag driver. This is the tool we're going to use to disassemble and put back together the knife. This flag driver with the included T8 bit is the only tool needed to disassemble the entire Smith blade. The Smith blade is held together with 7 screws. You have 2 here for the belt clip, 3 that hold the knife together, and then these 2 that hold in the detent plate. First, we're going to start with the belt clip. That's something that you might do to switch it to the second position or install your deep carry belt clip. The T8 bit comes out of the bit driver. As you're removing screws, I recommend inserting it in the front with the thick side at the back so you're not worrying about breaking the thin torque limiting section. We're going to start by taking out these 2 screws at the rear. Both the screws that hold on the belt clip are exactly the same and can be installed in the front position, and they are different from every other screw in the knife. From here, to actually take the knife apart, we need to take out these 3 screws. Start with the one at the front, that's the hinge pin screw. Once this screw comes out, you may notice that your knife might pop open a little bit. That's okay. If it also doesn't, that's fine. It just depends on the tolerances of all the components. Now we're going to move to the 2 screws at the back. Both of the screws at the back are also exactly the same as each other and different from every other screw in the knife. Once all 3 of these screws are out, you're going to want to pop the knife open. I just use the side of my finger and get under here to pop that up. Once the front's popped up, you can start to pull apart the back. I recommend grabbing it by the bottom and the top and just very slightly wiggling until it comes out. From here, we can start disassembling the blade pack. We're going to start with the bearing. Once the bearing's out, you can take the blade out. Now, the blade is very sharp, so be careful grabbing it. I recommend grabbing it by the top of the file and the flipper tab and lifting it straight up and out of there. Then we'll set it off to the side where it's not going to hurt anyone. At this point, you can remove the 2 pins that hold the knife together. You have your front pin and your rear pin. They are exactly the same and they are interchangeable, so don't worry about keeping them separate. From here, I'm going to lift up the front scale and push the hinge pin out. We can now see that the lower bearing is exposed and can be removed. At this point, we still have the 2 hardened metal shims that protect the titanium from the bearing in the knife. These like to stay in because of the lubricant. If you do need to get them out, you can just use the tool and just kind of pry them out. From here, there's one more easily removable component in your knife, and that is the rear bit retention magnet. It can sometimes be stuck in there a little, but with a bit of wiggling, you'll get it out. Now, for any of you who are curious about the replaceability of the fire steel, we do apply a bit of green retaining compound to hold it in so it doesn't rattle and accidentally fall out, but you can just break it out and install a new one if needed. The carbide glass breaker is also permanently glued in, but you shouldn't need to replace that, it is carbide. The bubble level is also permanently pressed into the knife. You could press it out, but it might not go in as well the second time. Last thing to note, the bit retention spring is spot welded into the knife. That is not a user serviceable item, so just be careful around there. Don't try to pry it out or bend it. It will be damaged, but just leave it as is and you'll be fine. You'll notice that the rear scale still has 2 screws installed, and those are holding the detent plate in. The detent plate is a hardened steel plate that helps lock up against the blade and has the detent ball in it to allow the nice clicky ratcheting as the knife's opening. That piece shouldn't need to be replaced or serviced, but if you want to do a full deep clean of your knife, you can pull it out and clean in and around there. To take out the detent plate, you just remove these 2 screws here. Again, like everything in the knife, the screws that hold the detent plate in are identical to each other and different from every other screw in the knife. When the detent plate is removed, and in general when your knife is apart, you want to be careful not to bend the lock bar. The detent plate prevents it from being bent too far out, and the blade normally prevents it from being bent too far in, but when the knife is open, it is possible to bend it and permanently deform it, and that would render your knife maybe not useless, but not working as well as it did from the factory. If you have a Founders Edition Smith blade, you may notice that on the inside, we have James's signature machined into the titanium, and mine right here. On all Smith blades, you'll also notice this bit of coded information in here. This tells you the exact date and time down to the second that your knife was made on. It also has the revision of the knife and the machine it was made on. Don't worry if the revisions don't match between the 2 parts. They are on different revision tracks. If I make a change to just the front scale, it only affects the revision number on the front scale. If you followed along properly, you're going to have your knife taken apart and all these pieces in front of you. Now let's put it back together. In this case, assembly is the opposite of disassembly. As you've noticed, as the knife's been disassembled, there are 3, well, technically 4 different kinds of screws. We have these long ones, which are the ones at the back that hold the 2 scales together. We have the medium length ones that hold the belt clip on. And we have these really short ones that hold the detent plate in. We also have the hinge pin screw, but that's pretty obvious, it's different. All of the screws except the hinge pins are all M2.5s, and the hinge pin is an M3 screw. We're going to start putting the detent plate back in. It just slots right into the knife, and we're going to put in the 2 screws in from the front. These screws don't need to be super tight because we're going to be tightening them down to final torque at a later step. Next, we're going to start on the blade pack. So I'm going to take the front scale, flip it over, and drop the hinge pin in. At this point, we want the Hacksmith logo facing upwards. That's going to help us later in assembly. We're going to flip it over. Now, if you notice, there is a flat on the hinge pin. We want that flat pointing towards the back of the knife at all times during assembly. So if it rotates, just kick it back into place. First, we're going to drop one of the hardened stainless steel shims over the hinge pin. Then we're going to take a bearing. If you notice, the one side has the exposed cups, and the other side has a flat top to it. We're going to make sure that in this case, the exposed cup is pointing down. So we're dropping that over cup side down. At this point, we'll drop in the 2 pins. One goes up front, one goes in the back. The blade comes next, and again, be very careful, this is a sharp blade. We're going to drop it in, pivot it over till it's in the closed position, and then we're just going to adjust the pin since it rotated a little bit. Now we're going to drop the other bearing in, and for this, we're going to have it in the opposite orientation with the cup facing up. Then it's the other hardened stainless steel shim. For installing the rear bit retention magnet, I like to stick it to the end of the bit in the correct orientation and drop it right into the slot. Now the rear scale goes on. As we drop it into place, we want to make sure that the pins all seat, including the hinge pin, but you just drop it on, sort of wiggle it into place, and everything will go nicely. Before we take our hands off and release the pressure, we're going to want to take the hinge pin and install it nice and loose for now, just to hold it together. We will torque it to spec with the bit flag in a minute. We'll drop the rear screws in, and these can be tightened down about as tight as you can get them with 2 fingers on the bit flag. Now, we can use the side of the bit flag that says pin on it, and as we tighten down the hinge pin, we want to be unbending the bit flag to the point that it just lines up with the lower part of the flag. As you're tightening the hinge pin, be very careful not to apply too much torque to the bit flag. If you bend it too far, it will break or overtension the hinge pin screw. If you do break your bit flag, we have an at-home 3D printable version that's meant to be run on any FDM printer at a PLI. At this point, we can verify the knife is working properly. Yeah, that works great. You may notice that the lock bar doesn't fully engage because the detent plate is sticking out too much. At this point, we're going to make the adjustment to the detent plate and tighten those screws down. We're going to make sure the knife is open, set it down so we're not at risk of cutting ourselves on the blade. We're going to back off the detent plate screws just a hair, and now we're going to tighten them down about as tight as you can get with 2 fingers on the thick side of the bit flag. And we're going to unlock it. I think we're good. Finally, we're going to put the belt clip back on. You can choose to put it in the front position to carry the knife blade point down, or in the standard position to carry the blade point up. I prefer it in the standard position, so that's where I'm going to put it today. Before we tighten them down, you're going to want to adjust the belt clip so it is perfectly straight and level. And then we can tighten them down. Same as all the other screws, 2 fingers about as tight as you can get with the thick side of the bit flag. You have now successfully disassembled and reassembled your smith blade. If you want to learn more about your smith blade, make sure to check out our other tutorials.